So this week, we're going to take a look at section 1.1. We're going to split it into two parts. We'll do part 1 today. We'll do part 2 on Wednesday. And then on Thursday, we're going to do section 1.2, but just the first part of it. So those are going to be the 3 lessons that we look at for this week. Let me show you guys on Schoology just so you can see those as well. Okay, so there's the lessons we're looking at this week. Lessons 1, 2, and 3. So if you're absent any day, that's where you'll find everything for this week. Just lessons 1, 2, 3. So some of the things that I show you guys right now, you don't have to write down. I just want you to look at it. I will let you know when there's something you need to write down on your guided notes. Okay. This is the first thing. Again, you don't have to write this down. I just want to read it and see if it makes sense. So when we're solving an equation, the most important thing we have to do is make sure if we do something to one side, that we do something to the other side. One property that we will use when we're solving equations is adding. We're going to be adding, subtracting, multiplying, and dividing. Those are the 4 big things that we use. We're going to start by looking at adding. The addition property of equality says that when you're solving an equation, one thing you are allowed to do is add the same number to both sides. And as long as you add the same number to both sides, it won't mess anything up. What you get will be equivalent to what you started with. Hopefully simple, because that's always the goal, to try to make whatever they give you simple. So any question on that idea, that you are allowed to add the same number to both sides of an equation? And when I say sides, it means something like this. You'll be given some information on the left, which I call side 1. You'll be given other information on the right, which I'm calling side 2. And if you want to add something to side 1, that's okay. Just make sure you also add it to side 2. You have to do it on both sides. So that's fine. So now we're going to look at how can we use that property to solve an equation. Well, what does that even mean, solve an equation? This is going to be the first thing you guys can write down on your guided notes. So right at the top, below your name, it says to solve an equation means, and anybody have an idea what that means? What do you think it means to solve an equation? What do you think we're trying to do when we solve an equation? Alex?
Get an answer.
Yeah, we're trying to get the answer. Right? We're trying to, usually there's a letter in it, and what we're trying to do is figure out, you don't have to write this yet, but we're trying to figure out what that letter is. That's the goal. To solve an equation means to find a solution. So on that blank where you see to solve an equation means, you want to write in what's highlighted in yellow. Find the solution. Let's see. So this part, I don't think I had a spot for that, so you don't have to write that part down. But what we're going to always be doing is getting the variable alone on one side. If you have a little bit of room, right where it says to solve an equation means, you might be able to just write this part down, because there's really 2 lines. So you can kind of squeeze it in on that small line, right above chapter 1, section 1. But that's the goal. We want to get the variable by itself on one side. So if there's stuff that's with the variable, we don't want that. We want to get rid of it. But we have to get rid of it the right way. If we don't get rid of it the right way, then we end up getting the problem wrong. So that's where we'll talk about the rules that we need to follow to do that. Okay, this part, you don't need to write that down. But on some problems, I might ask you to check your solution. Okay, so what that means is just take your answer and see if it's right. Right? We'll go through a problem where we do check it, and I'll show you guys how to do it. But you don't have to write that part down. Once we solve an equation, we need to check our solution. You don't have to write it. So I'll show you guys how to check your solution when we do one. Any questions so far? Okay. All right, so then the next thing on your guided notes, it says chapter 1, right below the part 1, solving equations by adding or subtracting. You've got some room to write down a couple things, and there's some dots. So this is the first thing you want to write down. So the first thing we want to do is find the variable that we're solving for. Okay, make sure you know where the variable is. And what we'll do is we'll do example 1 in a minute. Now you can write it down. I'm not going to do it quite yet. I'm going to give you the other bullet point first. But that's the first. Find the variable, which is always the letter, that's on one side of an equal sign. Now, it might be on the left. It could be on the right. It doesn't matter which side it's on. But that's the first. Now, if you look at example 1, is the variable all by itself? What do you think? Finnegan? Is the variable by itself? Mm-hmm. So there's nothing else with it?
No.
Yeah. Anyone else have another thought about that? Whether the variable is by itself? Yeah?
I would just think adding 9 to 12 so it's already.
Okay, so we're not worried yet about the steps to solve it. I just want to know, is the variable by itself? If it is, then we don't have to do anything. If it's not, then we have to worry about doing something, and we'll figure out what we have to do. But is the variable by itself, Abby?
It's not.
It's not by itself. Right? Why not? It has a what next to it? Yep.
It has a minus.
It has a minus 12 next to it. All right? So the variable isn't by itself because there's a minus 12 next to it. How are we going to get rid of a minus 12? Yeah?
By adding 12.
Right. We're going to have to add 12. What did he just do? He did the opposite. All right? So you take the number that's on the same side of the equal sign with the variable, and we don't want that there. We have to move it. Where are we going to move it? We're going to move it to the other side. But the key is, how do you move it? The way you move it is by doing the opposite of that operation. This is a minus 12. We're going to do a plus 12. So for today, the only two operations that you have to worry about are either adding or subtracting. Those are the only two. We are going to do multiplying and dividing, but that's not going to be till Wednesday. Okay, so on that third bullet point, you could write down the two operations for today for either add or subtract.
Can I please use the bathroom?
Yeah, just go ahead and sign up. right, so let's try these steps. So you guys have a little bit of room off to the side for example 1. So we already found the variable. In this case, it's x. We said that it's not by itself, so that means we have to do something to get it by itself. And what did we say we have to do to get rid of the minus 12? I think, Dorian, you told us. What did we have to do?
Add 12.
We're going to add 12. So what I'm going to do is put plus 12. But where else do I have to put plus 12? Yeah? Right, on the other side. Remember what we said. If you want to add a number to both sides, that's perfectly fine. But you have to do it on both sides. You can't just do it on one side. Right, so that's called keeping the equation balanced. You do it to one side, you have to do it to the other. Okay? Plus 12. And this is where combining like terms comes in handy. Because this plus 12 that we just wrote down doesn't have an x next to it. So we can't combine it with that x. So that x right here just gets copied down. Natalie, how about when we have negative 12 plus 12? What does that give me?
0.
0. And that's the whole point of why we added 12 to both sides. We wanted to get a 0 right there. So now, there's nothing on the left-hand side except x equals. And the last thing we have is 9 plus 12 on the right. So, Abby, what's 9 plus 12 going to give?
24.
Think again. What's 9 plus 12? Double check.
Oh,
How much?
23.
That would be if you added 11. You would get 23.
20.
If you added 8, you would get 20.
21.
Yep. 21. Okay, so x is 21. Now, hopefully, if you made a mistake, you would find your mistake because we're going to check it. All right, so that'll be the last thing that we're going to do here. We're going to check our answer. So on the 4th bullet point you guys got, just write down check. Check means to evaluate. We practiced evaluating last week. Evaluate means just take the number that you got, plug it in, and see if what you end up with works. If it works, then you did it right. If it doesn't work, then we did it wrong. All right, so Michael, what do you think our answer was in this problem? 21. So if I want to check my answer, I'm going to take the original problem. And what am I going to do with the 21? Not yet. No adding, subtracting, or anything. Yeah, first thing we have to do with the 21 is, yeah, Liv?
Replace it. Instead of x.
Right. First thing we want to do is take what we got and replace the x with 21. Okay, that's the first thing. So now we have 21 minus 12 equals, and I'm going to put a question mark there because we don't know if it equals 9. That's what we're checking. If it does equal 9, then we did it right. If it doesn't equal 9, then that means we did something wrong. Right, so Sean, if I do 21 minus 12, what does that give me?
9.
It does give me 9, which is what the problem said I was supposed to get, which means we did it correct. Right, so that 21 is the correct answer. If you plug your answer back in, like let's say you plugged in, let's say you got 13 for x. If you plugged 13 in, you'd end up with something like this when you were trying to check it. And then if you do 13 minus 12, Cadence, what's 13 minus 12 give me? 1. So when you get to this step, it says 1 equals 9. Is that right? Does 1 equal 9? No. So in this case, I would know that the number I plugged back in is wrong. Okay? 1 is not equal to 9. Right, so that's how you check your answer. Plug it back in and see if you get something that works. Like 9. Basically, when I say works, you should get the same number on each side. Any questions on that? All right. Does everybody have those 4 bullet points that they copy on the guided notes? All right. So let's look at example 2. Okay, so you've got a little bit of space. Not a ton of space, but this isn't going to be a very long problem. So it says 3 equals y minus 4. First thing I ask myself, is there something I need to do in this problem? Or is the variable already by itself? Caleb, what do you think? Is the variable by itself?
No.
No. Why not? What's with the variable that we don't want there?
-4.
Right, we don't want this -4. So we want to get rid of the -4. So he identified the variable. He knew it was y, because I asked him if it was by itself, and he said no. And he knew that there was a -4 with it. So now, we're going to do the opposite of -4. So Joe, what would I do on both sides here to get rid of this -4? Add what?
4.
Yes, very good. We're going to add 4, and we're going to add 4. Now we'll write down what we have. So Emily, what's 3 plus 4 give me? 7. Equals. Brady, what's going to come right after the equal sign?
Y.
Y. And my last step, Maya, what's -4 plus 4?
0.
0. That's the whole point. When you add or subtract, you hope that something comes out to 0. That's how you get rid of that. And Finnegan, am I done with that? Or do I have more I need to do?
More.
Okay, what more do I still have to do? So think, what were the directions for this problem? Up on the board. What does it say the directions are for example 2?
3 equals y minus 4.
Okay, so that's the problem, but what do the directions say to do with it? Solve and check. Have we done any part of the directions?
Solve.
We've done solve, yeah. So we know the answer. We just have to check and make sure that it's right. Okay, so we've done solve. And Sophie, how do I check if it's right? Yeah, we're going to plug the number back in. And Abby, what are we going to plug the number, where are we going to plug the number back in? For the y. And how about, Lexi, what number are we going to plug in? 7. Right? We're going to plug in the 7 and see if it's right. All right. So we're going to have 3. I'm going to put a question mark because I don't know if this is right. So 3 equals. And Dorian, what am I filling in right here? 7 minus 1. So it's the same problem. Just plug in the answer that you think is right and see what happens. 3 equals 7 minus 4. Sean, what's 7 minus 4 going to give me?
3.
Perfect. So is that true? Does 3 equal 3? Yeah. So we're done. Now, the difference on this one, we got 7 equals y. The number was on the left, the variable was on the right. That's fine. If you finish the problem, and the variable is on, where do we put it? Right here. The left, that's okay too. It doesn't matter what side you leave the variable on. Okay. Any question on this one?
Drop them.
Oh, okay. So any question on example 2? Alright, why don't you guys, I'll walk around and help people out if they get stuck. But why don't you guys try example 3 on your own. So 12 equals x minus 5. Okay, so 12 equals x minus 5. Alright, so I walked around and it seemed like most people did pretty good with it. So first thing, what's the variable in this problem? Let's make sure we know that. X. So that's the side of the equation you're focusing on. I don't really even care that there's a 12 on that other side right now. I'll care about that in a little bit. But right now, all I care about is that side. Because I want to make sure that there's nothing else on that side except an X. So Brady, right now, is there something else on that side with the X?
Yes.
What's on that side?
A -5.
A -5. So we don't want the -5. So what you want to think of is how do you get rid of a -5? Right? What do you do on both sides? You would add 5. Now I care what's on the other side because I need to know what am I adding 5 to? Oh, 12. So anytime you add something or subtract, I think we'll do a subtraction one and then, yeah, we'll do subtraction in a minute. You want to make sure that it cancels out. So in this case, Alex, what's -5 plus 5?
That's 0.
That's 0. So what I usually do is I just cross it out. This whole thing is gone. So Megan, on the right-hand side, what do I have left?
X.
Yeah, all I have is an X, and that's exactly what I wanted. Now I just have to see what's on the left. Abby, what do I have on the left-hand side?
12 plus 5.
Yep, and what does that give me when I do that out?
17.
Perfect. There you go. Now, as I walked around, I saw some people checked it, and they ended up with something that didn't work. All right, that's, you know, it's not good that it didn't work, but it's good that you checked it and you saw that it didn't work. So then you know, wait a minute, something's wrong. I need to go back and do it again. Okay, that's why we check it. Those of you that checked it and it worked, that's perfect because then you know you did it, you did everything right, and you're done. All right, so let's check it. How about Natalie? To check it, first of all, what number do I think is the answer?
What do you mean?
Like, what do we think the answer is in this problem?
X equals 17.
17. So that's what we think the answer is. How do we check if 17 is right?
You replace the X with 17.
Great. We're going to replace the X with 17. So just so you can see what we had before. We had 12 equals X minus 5. So now we've got 12. Maybe equals, we'll see if we did it right, 17 minus 5. Right? And Joe, if I do 17 minus 5, what do I get? Yeah, we get 12. So because 17 minus 5 is 12, and we had a 12 on the left-hand side, we get the same number on both sides. That means our answer works, and we're done. Question on that one? Right, So on those last three, we did add. We added 5. We did another one where we added 12. Now we're going to look at one where we do something a little different. This time, adding to both sides wouldn't help because we're trying to get rid of any number that's next to the letter. Right, so take a second and see if you can get the variable by itself. But my hint is adding on both sides isn't going to work this time. Alright, so just like the first property we looked at, it says you can add the same number to both sides. You can do the same thing with subtraction. But the trick is if you subtract something on one side, you've got to make sure you do it on the other. Alright, so how about Maya, what's my variable in this case?
X.
X. Is the X all by itself?
No.
No. So then we have to identify what's with it that we don't want. Then again, what's next to the X that we don't want? What kind of 6?
Positive 6.
Positive 6. We want to get rid of a plus 6. So we're going to do the opposite. Sophie, what's the opposite of plus 6? Yeah, we're going to do a negative or a minus 6 on each side. Okay, how about Abby? What's positive 6 minus 6? 0. The hope is that that happens every time. Okay? Plus 6 minus 6. Now, Joe, what do I have on the left-hand side?
X.
Just X. Everything else is gone. And on the right-hand side, we've got 10 minus 6, but we need to do that out. So, Lexi, what's 10 minus 6? 4. And there we go. So X equals 4. Aiden, can you remind me real quick how we check it?
We do X plus 6 equals 10.
Okay, so take the original problem. And what do?
You switch out the variable for 4.
Exactly. We're going to change the variable to what we think it is. 4. Fill it in. 4 plus 6. Again, I like to put that question mark because I don't know if it equals 10. That's what I'm hoping. If it does, I did it right. And Liv, what's 4 plus 6? 10. Does 10 equal 10? Do we get the same number on both sides? Yep. That means we did it right. Okay. Any questions before we look at the last problem? All right, so the last problem, I think you guys have it written down. Is a word problem. And what I generally am looking for on a word problem is I will look for two things. Okay, one, can you figure out an equation? I'm actually more interested if you can figure out an equation than you can the answer to the problem. So this says the price of a shirt was X dollars, and it increased by 7, and it's now 32. Write and solve an equation to find the original price. Can anybody tell me something in that sentence that's going to be important? We're just going to underline some of the important things. Some of it's not important. Yeah, Brady?
The price of the shirt was X dollars.
Okay, so yes, X. That's important because we're looking at a variable, and that's our variable. So we have to use an X. Something else that's important, yeah?
Increased.
Yeah, increased. That tells us an operation. We'll come back to that. But that's very important. What else?
There's original or equivalent.
So what else? Tell me, what did you say? What else is important, Joe?
Original price.
Okay, so that's what we're going to be finding, the original price. I don't think we're going to have to write that down separate from the X because the X is the original price. So the price of the shirt was X dollars. That's the original. Okay, so we've got that. Anything else that's important? Yeah? Okay, so that's the directions that we have to do. How about anything else that we're going to need to make the equation? Yeah, directions are always important. Yep.
$32.
Yep. Any of the numbers, that's important. There's one more word there that's really important. That's going to translate to a symbol in math. Without this word, you wouldn't have an equation. Yeah, 8. Okay, so not solve. That wasn't not the one I was thinking of, but that's part of the directions. So that's important. But something else that's going to translate to a symbol. Yeah?
Is it find?
No, not find. Joe?
Now.
Price increase is close. It's a word near there. Yeah? Is. Whenever you write is in math, is always translates to equals. Without the word is, you don't have an equal sign. Without an equal sign, you don't have an equation. All right. So it says the price of a shirt was X dollars, and that price increased $7. What operation is increased? Yeah? Addition. So something increased $7. What? What increased $7? Yeah?
The shirt.
And how did we represent the shirt?
X dollars.
X. The original price of the shirt increased by $7. And then it says is 32. So after the price increased by $7, it now is 32. What did I say is means? Equals. And what's on that other side? Yeah? 32. So the original price increased by $7, and now it is $32. We do need a dollar sign on the final answer, but you don't have to put the dollar sign in the equation. Okay, so that'd be the first thing I'd look for. If you got that far, you get half of it. Just forgetting the equation. Now, the second thing I'd look for is, can you solve it? Anyone think they could tell me how to solve? Yeah, go ahead, Brady.
So you subtract 7.
Yep.
On both sides.
On both sides. And what does that leave me with on the left?
On the left, leave you with 0.
So this part's gone. Anything else on the left?
In X.
Yep, just an X equals. And 32 minus 7 gives me, how about Kate's? 25. And what did we solve for? Because I want to make sure we put a label on this. And what was X? What did that represent in the word problem? Dollars, right? X was the price of the shirt, which in this case was dollars. So make sure you put a dollar sign on 25. Any questions on that? And it didn't say to check it, so we don't have to check that. Yes?
Where's your hole punch that you mentioned earlier?
Yeah, I'll get that for you in 1 second. Yep. Okay, so let me fix that. So make sure that you have some way of organizing the handouts. You can put them in a binder, you can use a folder, either way. Make sure you have your Chromebook. Okay, so when we go over homework, you can follow along. And the first test will be this Friday, September 2nd.